Hi again. Last tutorial I showed how to use the file to create the solution on a parallelepiped with the standard values, the default values. Let's now learn how to change some values. So we use the POD in the central part. Suppose we don't want to use it. We just have to put false here and we will solve the problem without arcade mode. And here if I put false, I'm gonna avoid computing the POD basis, which can be long. So let's run again this file. So I'm the iteration 2/3, 3/3, and we are done. Just waiting for the exact solution to be computed. There we have the error with respect to the MATLAB computed solution and the error with respect to the FreeFM computed solution. And by the way, in the last video I did not show how to visualize the results, but if we have a paraView here, I can just open the figure folder by going in podHimod. I was in rectangle. Here I have the figure folder. Just open it and I have my solutions which I can open, and once I open them, there I have a solution, and I can cut this rectangle to see what's inside. There we are. This is the middle part. And for the other parts, I have the left solution here and the right solution here. Let's open them. I can apply. I have some errors which are not important. Choose the solution, coloring scheme. So I see now the solution, how it is. And I can, in the same way that I did for the middle part, I can just cut this section and see what's inside. Same for the right part. I can cut this section and see what's inside. So here is the middle part of the solution that I had, and I can check the middle part like this, and there we are. So going back to here, now we did without the POD, the POD. Let's now assume that we still want to do the POD, so I put the training back to true and the solving back to true. But now assume that I want to do the POD, the polynomial interpolation for the POD. I can do this, and I want as degree the polynomials of degree 3, and I can run the file again like this. So this is the POD training. So we are solving 100 problems. Can open up this folder, maybe we can see more. And we see a much higher error. If we choose a problem, that it's not that which solution at the boundary between the central part and the left and right part can be interpolated well represented, let's say by a polynomial of degree 3, the solution might be much better. And finally, what I want to do, I comment this part because it's not of relevance with what we had before. Last thing we can do together is to show how to change the number of modes in the left and right part. For the middle part, we can just change here the discretization of the middle part, also its length. But for the Akai mode, we have to go in data left and data right. Let's go in data left. Here we see the number of modes and the number of elements and the elements type. So the number of element was 20 and the number of mode 50. I can go back to 10 and 10. And I can do the same for the right part. 10 and 10. There we are. I go back in the main solver. I put back the interpolation to false, and I can run the test case. Perfect. So this is the POD training. Recall that we had an error of about 6% in this case. Let's see what we're gonna have now. It's finished. 10%. So it's a bit worse. We can also decide to check up the new solution with VTK. Yep. Select solution for the left and right. So this is my cube that I can then cut with my slices. There we are. I mean, it's 10%, but I don't think we will see the difference with VTK. It's still quite good solution. And if I go close, yeah, we won't see the difference with VTK. Okay, thanks for watching, and don't hesitate to ask any question if you have any.